All right. Hey guys. All right. So this is simplifying within underneath a radical. The easiest way to do this is to just become really comfortable with your square roots, honestly. Play with them and understand them. Okay. So if you remember back in the day, we broke up numbers like 24. Okay. We broke them up and we asked ourselves, is there any perfect square that goes into 24? Remember, perfect squares. Here we go. 1, 4, 9, 16, 25, 36, 49, 64, 81. These are the beginning ones, 100, 121, 144, and onward. Another couple common ones are like 225 is really common, 400 is really common, 20 times 20. So these are really common ones that they use a lot. Okay, but we're looking, does any one of these go into 24? And 4 does. So if you remember, we broke this up like this. Okay, and then we took out the 2 and we got 2 root 6. Okay, we're going to do the exact same thing with the 24 here. The difference is that we're going to start messing with these exponents on a variable. And this is actually way easier than it might seem. For example, the square root of a squared is equal to a, correct? Well, what's the square root of a to the 4th? That's going to be a squared times a squared, right? Okay, so you kind of can start to see what's going to happen here. What's the square root of a to the 6th? That's a to the 3rd times a to the 3rd. So you can kind of see that it ends up being dividing it by 2. Yeah? Okay. So because of that, we're going to break this up. This thing is going to be broken up to 4 times 6. Break it up into pieces. And then that's going to just be w to the 6th. Or actually, no, let's not do that. Let's not jump. I'm not going to, no, let's not do that either. Let's see. Let's do this. The square root of w to the 12th. This, I cross it off, and I'm going to write w to the 6th. This is 2. So the answer is 2w to the 6th times the square root of 6. I often think of this, it's kind of stupid, but I always call this like the house, okay? You can't take anything out of the house until you find the square root of it, okay? And when you're operating with things, whatever's on the outside can operate with the outside. And whatever's on the in operates on the in, okay? It's sort of like they talk to one another. They're inside and outside. It's a kind of a weird analogy, but it does help sometimes to kind of think of it that way. Okay, let's try. Next one. Oh, come on. Boom, backspace, boom. There we go. All right, so take a look at this one. It's really easy to do even numbers. Okay, but what happens if you have an odd number? So if you have an odd number, what the trick is you just take the next even, the closest even number. Get it? Because 20, v to the 20th times v to the 1st is v to the 21st. And then this is v to the 10th. Okay? V to the 10th times v to the 10th is v to the 20th. Okay? Square root of v. And that is your answer. Okay? So anytime you have an odd number, if you have the square root of x to the 9th, just rewrite it as the square root of x to the 8th times the square root of x. That becomes x to the 4th, and you're done. It's x to the 4th times x. It doesn't even matter if it's a huge number, like a to the 1001. Just go to the lowest, the next even number, a to the 1000th, okay, times the square root of a. And 10 times 10, 1000 doesn't have a square root. Let's pretend it's there. That has a square root. That's a to the 100. Okay, so this is a to the 100 times a. All right. Next, back. Let's try another one right here. Okay, so in order to do this one, let's pull this up a little bit. Okay, so there we got a number now inside here. Okay, oh no, what are we going to do? It's the same thing we've been doing. Rewrite it. Ask yourself, is there a perfect square that goes into 8? And the answer is yes, it's 4. 4 times 2 equals 8. Break y into the next lowest even number, and y. This becomes y to the 6th, and this becomes 2. So the answer is, take the stuff on the outside and put it together. Okay, 2y to the 6th. We pulled y6 out. Remember, y to the 12th was in. We found the square root, it came out. We found the square root of 4, it came out. So we put what's on the out and then put what's on the inside. 2 is still inside, and so is y. 2 is there, and y is there. Okay. All right. Hang on a second. I guess I should do one more like that. Okay. Maybe. Watch this if you need to. Okay. If you need another problem, we could just make one up. The square root of, let's say, 44, x to the 6th, y to the 11th. Okay. Break it up. 4 goes into 44. 4 times 11 is 44. X to the 6th is even, so we can leave it. Y to the 11th, break it down, take it down to the next lowest even number like that. Okay? Square root of 4 is 2. It's on the outside. Square root of x cubed, x to the 6th is x cubed. The square root of y to the 10th is y to the 5th. And now we have 11y that's left on the inside, and all of this is on the outside. So you list what's on the outside, and then you list what's on the inside. And that's it. Okay. All right. Next, let's try this one. All right, now you're wanting to add and subtract. Okay, so these feel a lot like terms. In order to add them, they have to be the same. So the rules are like square root of a plus the square root of a. Well, think about this. If you have one square root of a and another square root of a, you got 2 square root of a's. Okay, much like x plus x is 2x. Exactly, feels the exact same way. Okay, if you have 3 square root of 2's minus a square root of 2. Well, you had 3, you subtract 1, you're left with 2 square root of 2's. See the rules? Okay, it's just basically if they're the same, you're adding the coefficients, yes? Okay, it feels a lot like adding like terms, but we don't have like terms here, so we need to break these down into something that we can add together. So let's break these down. 98 is it divisible by 4? 4 goes into 9, 18. No, it's not. Let's try 2. Is it divisible by 2? 90. I know 2 isn't a perfect square, but it might give us a perfect square. 2 goes into 9 4 times 49. Yep, 49 is a perfect square. So 49 times the square root of 2 plus, and 32 breaks into 16 square root of 2. 16 is a perfect square, is the biggest perfect square that goes into 32. All right. So now we have 2 times the square root of 49 times 2 plus the square root of 16 times 2. So let's simplify. Square root of 16 is 4. Square root of 49 is 7. And 2 times 7, 14 square root of 2 plus 4 square root of 2. And the answer is 18 root 2. All we did was break it down and simplify it. Let's see if I have another one of these problems. I probably did. No, I didn't. Let's go back. So if you wanted to do something like, okay, second problem, if you will. Let's say you had 3 times the square root of 30. Sorry, let me think. Let's do 32. No, I don't want to do that. Hang on. Sorry, I'm making this up on the fly. So I want to make sure I do a problem good. Okay, so let's do 75. Okay, and let's do minus 8 times the square root of 48. Yeah, I think that'll work. All right, so you want to break these up. So a perfect square that goes into 75 is 25. It's 25 times 3. And a perfect square that goes into 48, you can try 4, right? 4 is the perfect square. And then you get 4 times 12. But 12 also has 4, right? 4 times 4 times 3, right? So actually, the biggest perfect square is 16 times the square root of 3. 16 times 3 is 48, okay? Had you broken it up into 4 times 4 times 3, that would have been fine too, you guys. It would still work, okay? So square root of 16 is 4. Square root of 25 is 5. 3 times 5, 15, root 3, minus 8, no, 32, sorry. 8 times 4, 8 times 4, which is 32, root 3. Okay, now it says I have 15 root 3's and I'm taking away 32 root 3's. All right, so I'm going to end up with a negative number. It's going to be negative 17 root 3. We keep these the same because all we're doing is talking about them. We're not simplifying them anymore. All right, next. Now we're going to multiply. The rule is, okay, the way it goes is if it's out, in, out, in, we're going to multiply the outs and multiply the ins, okay? Like it's like they talk to one another, okay? So in this case, there's only ins. So we're going to multiply underneath the radical. It's 2y times 3y, which is the square root of 6y squared. And then you always have to ask yourself, can I simplify it further? And you can, because you can break it up into 6 times the square root of y squared. And you can take that square root of y squared. It's y. So you get y square root of 6. And then you are ready to go. Okay? So if you had the square root of 5x to the third times the square root of, I don't know, 3x to the fifth, that is going to be, okay, that is going to be 5 times 3 is 15. It's still underneath the radical, x to the 8th. Because x to the third times x to the 5th is x to the 8th. And then you can simplify that. Square root of 15 times the square root of x to the 8th. That becomes x to the 4th. And this is x to the 4th times the square root of 15. Okay, next. Now we're going to go, oh, here's another one. Okay, good. Another example. This one is nice. It's kind of fun because look, you can't simplify either one. You multiply, you get 36y to the 9th. And so if you separate that, you get the square root of 36 times the square root of y to the 8th, the square root of y. And now you can simplify. Take these square roots. And now they're on the outside, so they go on the outside. And that guy stays in the inside. All right. I actually probably wouldn't have done it this way, to be honest with you. That was kind of the longer way, or maybe more. I don't know. To me, I would have done this. I would have immediately taken out y to the 8th, taken the square root of y to the 8th, and I would have gotten y to the 4th times the square root of 36y, and then taken out, and you get 6y to the 4th, square root of y. It doesn't matter which way you go. It really doesn't. What matters is you keep your rules clean, okay? Ooh, no, they think it's harder because now you have the distributive property. It's super easy. Just distribute and multiply. So there's a 1 on the outside, so 7 times 1 is 7. Square root of 3 times 15 is 45. Okay, minus 7 root 3. Okay, you have to ask yourself, can I simplify this further? And you can, because 45 is divisible by 9, which is a perfect square. Remember, 1, 4, 9, 16. 9 goes into 45. So that becomes 7 times the square root of 9 times the square root of 5 minus 7 square root of 3. So then, oh, wait, how did I get 7? Oh, I did. No, I did. Oh, I forgot to multiply it by the 3. I'm so, okay, sorry. On this one right here, I made a mistake. It's not 7. Whoa, I don't want to do that. Hang on. Come on, honey. Okay, I made a mistake. Do you guys see it? I'm going to do it in red so I show my mistake. 7 times, I multiplied it by 1 for some reason, and I put 7 root 3. That was stupid. It's 7 times 3, which is 21. Okay, so I can erase this one. No, I can't. My box is so big, it won't let me do that. Where's it going? It won't come back even with Control Z. Oh, well, whatever. There we go. We still have the problem. It's right here. Okay, that was wild, you guys. Okay, simplify. 3 here. Okay, and I get 21 root 5 minus 21 root 3. And you might be tempted to put these together because they match with the 21, but don't be. They are not like terms because root 5 and root 3 are totally different things. So you have to just leave it. That is the answer. It is what it is, what it is, right? All right. I'm sure I did another one of these. I know I did. There's, okay. We'll end up doing that one. All right. So there is a rule when you're working with square roots, okay? You cannot leave a square root in the denominator. Do not leave the square root in the denominator. So we need to rationalize. Now, we have done this before. Rationalize the denominator. We did that with imaginary numbers, if you remember. So to rationalize it, you are going to multiply it. Okay, multiply by its it's like sort of its multiplicative, its converse, but you know what? How about I do this instead? Multiply to make it rational. I know that's kind of lame, but you'll see what we're going to do. So here, to multiply, to get rid of that square root of 5, we need to multiply it by the square root of 5. And that will get rid of it. But you just can't multiply the denominator. We need to multiply it by 1. This is just a really funky form of 1. Square root of 5 over square root of 5 is 1. So multiply across and you get the square root of 30 over the square root of 5 times the square root of 5 is the square root of 25. 25 or 5. And the answer is just the square root of 30 over 5. All right, and that's all you do to rationalize the denominator. So if you had 8 square root of 2 over the square root of 3, we would multiply by the square root of 3 times the square root of 3. And I would get 8 square root of 6 over the square root of 9, which is 3. So I'd get 8 square root of 6 over 3. And that would be the answer. Now, if these were reducible, you would, if these had the same factors, you would reduce it, but they don't. Next. Okay, FOIL. This is a first, outer, inner, last thing. Okay, so we're going to do that. I'm going to rewrite it. 4 root 10 minus 5 times 5 root 2 minus 1. Remember, these numbers are stuck together. This is one number. This is one number. I mean, I know it consists of 2 numbers, but it's one, like real, one number. So we're going to multiply. First, multiply the outsides, multiply the inside. 10 times 2 is 20. Outer minus, multiply the outside, multiply the inside. Inner, multiply the outside, inside, whatever's there, and then plus 5. Then you need to add like terms or simplify it if you possibly can. Okay, now it might be tempting to try to figure this out. 20, okay, so 20 can be divided. Okay, 24 goes into 20. So 20 is divisible by 4, which is a perfect square. But the square root of 10 can't be broken up. There's nothing that goes into 10, so we have to leave it. And we can't do anything with these numbers. You can't add them together. They're not like terms. But this one will simplify. So we get 40 root 5 minus 4 root 10 minus 25 root 2 plus 5. And that's really interesting. I actually don't know what the proper order is. I would suspect it might be in numerical order like 2, 5, 10. But I'm not sure. Let me know. Let me know what Alex wants you to do. I'm kind of curious. Let's see if I have another one of these problems. Nope. I do have another rationalize the denominator one. Okay. And this one is simply going to be, I think this is exactly the same one that we just did. So let's not do that one again because that makes no sense. Let's do this one. Okay. So it's inside, the whole thing is inside the square root. So the first thing we need to do is rewrite it like this. Okay. Then you want to rationalize it by multiplying by the square root of 10 over the square root of 10. And you get the square root of 60 over 10. Because the square root of 10 times the square root of 10 is the square root of 100, which is 10. Okay? Can we break up 60? Is there a perfect square that goes into 60? 4 might go into 60. Square root of 4 times 15. Yep. Over 10. Square root of 4 is 2. So we get 2 root 15 over 10. And then you can divide that by 2. So you get the square root of 15. 2 goes into 2 once, right? And 2 goes into 10 5 times. And that's your final answer. Okay. All right. I'm intentionally not doing a ton of these problems because I do believe that you guys will understand them as you work on it. Okay, this is probably the most difficult one to rationalize, but it actually should ring a bell because you guys, do you remember when you did? I'm just going to put remember when? Remember when? Remember when you were a young lad? Okay, and you had like this 2 plus I. And I said we couldn't leave the I on the bottom, and we multiplied it by its conjugate. But we had to do it on both the numerator and the denominator. Okay, this is very much the same. All we do is multiply by its conjugate, which is this. But if you do it on the bottom, you must do it on the top because it's just that weird form of 1. Okay, now I'm going to have to distribute. Boom. So I'm going to get negative 30 minus 10 root 3 all over. And this is going to be a FOILing problem now. So first is 36. Outer is going to be plus 12 root 3. This one's going to be minus 12 root 3. And then the last number is going to be minus 4 times root 9. These two will cancel always. They're going to always cancel, you guys, because that's the whole point of doing this. Negative 30 minus 10 root 3. No, you can't add them. Okay. 36, this square root of 9 is 3. 4 times 3 is 12. So I get 36 minus 12, which is equal to negative 30 minus 10 root 3 over 14. No, 24. 24. Notice all three of these numbers are divisible by 2. So we can simplify it. Okay, are they divisible by 4? No, because 4 doesn't go into 10. So we are going to factor out a negative 2, and we're going to write 2 times 15 minus 10 divided by 2 is 5 root 3. So all I did was divide the top by 2. Okay, and then we're going to factor out a 2 here, right? 12. Do you see what I did? I factored out a 2 and I factored out a 2, and this 2 will cancel. Okay, and you will get negative 15. Okay, plus. My bad. If I factor out a negative, I'm going to get plus. Either negative 15 plus 5 root 3 over 12. Or most likely they would have left that negative in. It could be either one. This is probably the better choice. All right. I guess that's it. Okay. So I didn't have a second problem of that. Okay. My question is, maybe you need it. I think maybe I should do one more. Okay. So say you have 3 plus the square root of 8. Let's not pick 8 because it has a perfect square that goes into it. 6 over 2 minus the square root of 5. Okay, to get rid of that square root, we would multiply it by its conjugate, which is 2 plus root 5. 2 plus root 5. Same numbers, just change the sign. Now we got to do FOIL on the top and the bottom. So 3 times 2 is 6, plus 3 root 5, plus 2 root 6, plus root 30, all over first 4 plus 2 root 5 minus 2 root 5 minus the square root of 25. And then we simplify it. Okay, look on the top. None of these are like terms. And 30 is not divisible by 4 or 9 or 16. So you can't break up 30 into anything meaningful. Okay, so we've got to just leave it. 6 plus 3 root 5 plus 2 root 6 plus the square root of 30 all over. And then these two cancel out. Square root of 25 is 5 over negative 1. And that negative 1 would literally just change all of these signs and you'd get, because if we divide every single one of these by negative 1, this is what would happen, and that would be the answer. Well, sorry about that. That's one ugly. Square root of 30. Let's try that again. All right, and that's it.